Okay, so let's see. There's some. I'm streaming for the first time, so let's see how to fix it. I hope I'll be able to share my screen. Share. Close. Okay, I'm streaming for the first time, so new issues keep coming up. So let's hope I can share screen now. Shall we share entire screen and share. All right, so let's see if this works. Okay, hopefully the screen is visible. All right, so let's get started. Okay, so we're gonna solve this paper. I hope this is visible. So let's just check with my students who are around whether it is visible or not. Is the screen visible? Okay, so let me increase the volume. Yeah, thank you. Okay, so the screen is visible, right? So right, so let's get started. Okay, so we'll solve the NMTC paper. I might switch between teams and this thing to see with my students because I cannot see the screen right now. Just figuring out how to set it up. All right, so this is welcome to NMTC 2024 on the spot. And we plan to crack this entire paper within 2 hours, okay? Because it's a 2-hour paper actually anyway. Should be able to do it faster. Okay, let's start. So let's get it started. Let me just make sure once more with my students who are on the stream whether this is clear. So, Pradhin, is it visible? Yes, it's clear. Okay, Naman says it's clear. All right. Okay, thanks. So Naman gave me this paper actually. So all right, let's get it started. So the first question is if x square plus x is equal to 1, then the value of x power 7 plus 34 by x plus 2 is. Okay. How do you solve this problem? If x square plus x is equal to 1. Well, one way you would try this is to solve for the quadratic and maybe play around with it. That you can try to do the quadratic formula, but it will be actually quite complicated if you did that, most likely. Okay. So maybe you can play around with, try to reduce what x power 7 is in terms of x. One standard way to do it is to compute what x power 7 is. Like for instance, x square plus x is equal to 1. Then you can multiply by x again and you get x cubed plus x square is equal to x. Now again put back x square is x minus 1. X cubed plus x minus 1 is equal to x. And then you see x cancels. And I hope I did it correctly. So if you multiply x throughout, you get x cubed plus x square is equal to x. And what I did is, after I multiplied x throughout, I replaced x square here by x minus 1. Okay, so replace x square by x minus 1, and you'll see that x cube is equal to 1. But that seems wrong actually, because x square plus x plus 1 equal to 0. Solution is x cube is equal to 1. Let's see. So omega square plus omega is not 1. So what's the mistake? So let me just see it again. So x square plus x is equal to 1. Multiply x again, you'll get x cube plus x square is equal to x, and x cube plus x square plus x is equal to 2x. Yeah, okay, fine. Now it's correct. X cube plus 1 is equal to 2x. Okay. So in other words, you get x cube is 2x minus 1. Thanks. So 2x minus 1. And once you get x cube is 2x minus 1, you can try to simplify this further. So for example, what happens if you do x power 4? You get 2x square minus x. Again, you can replace x square as 2x minus 1 minus x. So you'll get 3x. Sorry, you'll get not 3x. You'll get 2x minus x minus 2. Okay, so x power 4 is x minus 2. One thing you can do at this point is, if you want, just multiply x power 4 and x cube. You'll get x power 7. Okay, so x power 4 is x minus 2, x cube is 2x minus 1. So x power 7 is 2x minus 1 into x minus 2. Okay, and if you do this, you will get 2x square minus 4x minus x plus 2. So you'll get 2x square minus 5x plus 2. And now you can again simplify and get 2 into x square is again x minus 1 minus 5x plus 2. And you'll get essentially minus 7x, no, minus 5x. I'm sorry, 2x minus 5x is minus 3x minus 2 plus 2, which is equal to minus 2 plus 2. So I seem to be getting minus 3x. Okay, I hope that's correct. I'm prone to making calculation mistakes. So if you get minus 3x, what is minus 3x by x plus 2? So can we simplify that? Wait, so did anyone do this? Maybe I can ask them in chat. Is it clear? So is the stream not visible? So I think Pradyum notes that I made a mistake. X square is visible. Okay, thanks. X square is 1 minus x. Oh, okay. All right. So, x square is 1 minus x. That's a mistake I'm making. Okay. All right. So let's just note it. I think Nabanyu noted, one of my other students noted that one nice way to do it is that he notes that you could approximate the values. Like x square plus x equal to 1, you could approximately see, because it's one of the multiple choice questions, right? So we could also do that. Let's do it both ways. So let's quickly do it both ways. If you look at x square plus x is equal to 1, well, as the notes, x square should have been 1 minus x. I kept writing x minus 1. So if you look at, yeah, so I'll have to fix that. So let's see if I can do it quickly by repeatedly squaring it, right? X power 4 is x square minus 2x plus 1. And x square is again 1 minus x. So it's 1 minus 3x plus 1. So it is 2 minus 3x. And if you look at x power 7, it is x power 4 into x square. If I do, I think x power 4, maybe we should do x power 8, square this again. Why not x power 8? Squaring is faster, no? So let's do that. 2 minus 3x the whole square. 4 plus 9x square minus 3 2s are 6 2s are 12x. Okay, which is 4 plus, thank you, Pradyum, 1 minus x. And 4 plus 9 is 13 minus 9x minus 21x. Okay, 13 minus 21x is x power 8. Now, what is the use of doing x power 8 when you have x power 7? Well, you can multiply by x power 8 above and below, right? So you can do this, x square plus 2x. Okay, so x square plus 2x, x square plus x is already 1. So x square plus 2x will become just 1 plus x in the denominator. In the numerator, we already have x power 8 plus 34x. So if you add 34x, you'll get 13 plus 13x. So we are done. 13 plus 13x divided by 1 plus x is 13. So answer is C. Okay, answer is C. So basic idea was you just repeatedly square. It's faster. X square, x power 4, x power 8. Even if you have x power 7, you multiply by x above and below. Okay, so that's the plan. All right, so we can erase that and we can try an Abanyu's quick technique. Okay, Abanyu's technique. Let's go back. Okay. So what another student of mine said was, why not approximate? So in other words, use quadratic formula and maybe approximate. Well, as long as it's a real number, it's fine. It's complex can get tricky. Not that you can't approximate complex numbers, you can, but it can get tricky. But here maybe it's not. So what is, if you apply the quadratic formula, what do you get? Minus 1 plus or minus b square 1. Yeah, in this case it's plus 4 by 2. So it's like minus 1 plus, oh, this is Fibonacci, that's why, I guess. I mean, this is the x square plus x equal to 1 is essentially, this is the golden ratio, right? So once you have the golden ratio phi, you can sort of say the answer can be root 5 plus 1 by 2 or root 5 minus 1 by 2. So let's say you take root 5, one of the roots you can take is root 5 minus 1 by 2. And root 5, I guess, is what Naman is saying you can approximate. So it will be like, I think the famously it is 1.618 is one of the answers, I think, right? So how much is root 5 minus 1 by 2? Is it 1.6 or something like that? So 2.32 minus 1, 1.3, I think it's around 0.618. So if you know 0.6 is the answer, then you don't have a calculator, but you have to approximate 0.6 power 7 by plus 34 by 2.67. But you have to still calculate this, right? Still calculate this. This one can be a little tricky to estimate. Okay. Anyway, so I think this is basically Fibonacci. The main trick here, or the main technique here to remember is that, I remember now, is that if you look at any x is basically the solution to this is the golden ratio, phi square plus phi is equal to 1. And it turns out that phi power n, if you notice, will come in terms of Fibonacci numbers. I think the answer will be something like fn phi minus phi minus fn minus 1 or something like that. Okay, where fn is the nth Fibonacci number. We already, I think, sort of saw it. So if you notice, the Fibonacci sequence is 1, 1, 2, 3. You keep adding the previous two. 3 plus 5, 8, 8 plus 5, 13, dot, dot, dot. And if you look at, already we saw that phi square is equal to 1 minus phi, 1 comma 1. Phi cube is equal to phi minus phi square. That is phi minus 1 minus phi, which is 2 phi minus 1. Can you guys see it? So it's 2 comma 1, 2 comma 1, right? And you can check phi power 4, we did by squaring that time, is essentially 1 minus phi the whole square, which is phi square minus 2 phi plus 1. And phi square is 1 minus phi again. So it's 2 minus 3 phi. Can you guys see it again? 2 comma 3. So it turns out this is like one of the standard Olympiad type problems, like trying to give golden ratio. I should have spotted it. So phi power n, if you take the golden ratio, if you want to raise it to the power n, you can write it as the Fibonacci number times phi minus, I guess, fn minus 1, something like this. Okay, I mean some consecutive number, I think, like phi square is f2 phi minus f1. So it's phi minus 1. Okay. All right. Okay, so hopefully everything is fine. We can go on to the next problem. Are there any comments? Okay, thanks. So let's move on. So the next one is the angle between the hour hand and the minute hand of the clock at 9:38 p.m. is, okay, I can see the comments in my other screen. Okay, thank you. So, all right, so let's see, let's read the question. The angle between the hour hand and the minute hand of the clock at 9:38 p.m. is, what is the angle? So is it 60, 61 degree, 59 degree, or 62 degrees? Right. So how do you do this problem? So you have basically 12, 9, 6, 3, and you want to look at 9:35, 7, and 8. So you want to know what is the angle between the hour hand and the minute hand. Obviously, the minute hand at 9:38 is wherever, right? We know exactly where it is. The question is how much, by what fraction of the angle would the hover hand have moved, because the hover hand has to move constantly at a rate of one, constantly at a rate of whatever, 9 to 10 it has to move, which is essentially 360 degrees by essentially 12, right? So it has to keep moving 30 degrees at a time, right? It has to keep moving 30 degrees at a time because it has to move totally 12 units of this thing. So for it has to move 30 degrees in 5 minutes and 30 degrees in 1 hour, right? So it has to move, hover hand has to move 30 degrees in 1 hour. So it moves at a rate of 30 degrees per 60 minutes. Okay. And if 48 minutes have elapsed, 38 minutes have elapsed, if 38 minutes have elapsed, then what is the fraction? That's the question. So then 30 into 38 by 60, that much degrees it would have moved essentially, right? Um, so we know exactly where it is and we know what 8 is, so we should be able to calculate now, right? So 8 is 8 into 30 degrees. That's, sorry, we know it in 38. Where is this now? What's the calculation? I think you have to do, don't calculators were allowed, right? So you have to make an estimate, maybe that's the problem. So it's 30 by 60 is anyway 2, and this is 19. So you would have moved 19 degrees, correct? So it would have moved 19 degrees. So starting from here, it would have essentially moved 19 degrees from 9 to 10. Okay, 19 degrees from 9 to 10. And at 9:38 p.m. it is, where is this at 38 p.m.? So 9:40 it is essentially 30 degree. So in other words, here let's see it carefully. 9, 8, 7, 10. And here it has gone, the hover hand is somewhere here, 19 degrees ahead. Okay, hover hand. The minute hand is somewhere here, which is basically, um, where is this? This is essentially 38 is 3 degrees ahead of, or 2 degrees. So sorry, 2 minutes, 2 minutes out of 5 minutes, right? 2 minutes out of 5 minutes into 30. So so basically 12 degrees here, right? Sorry, is there any other comment here? Correct. So all right, so you can just calculate now what the answer is. So what's the answer? Answer is, I guess, my, according to me, the answer is 19 plus 12 plus 30, which is 11, 6. Yeah, that's correct. So if you already know, yeah, that's correct. So some of the students are noting in chat that you could have directly noted that the hover hand goes half degree per minute and the minute hand goes 6 degree per minute and directly calculate. That's correct. Okay, awesome, very good. So we are done with this. So let's do geometry. Geometry, quick. Let's do geometry. I want to do it. Let's do faster. I think I'm spending a lot of time on each problem. So, okay, so here you have a question where you have AOB is the diameter of the circle with center O. PC and PD are two tangents given to you. Then the measure of angle EPD is. Okay, so let's try to understand the question. So it's scribbled it. So let me just try to draw it separately here. So you have AOB is the diameter of a circle, AOB. Okay, and PC and PD are two tangents. PC and PD are two tangents. Okay, then the measure of angle EPD. Wait, what is E though? Okay, in the picture, I think you see that dropped a perpendicular. Maybe that was the question. So 90. So from the question, you have, I think they marked 90 there with black. I can sort of see. Okay, and then have they given some angle 30 degrees or something? Is that given? Looks like it's typed. Was it given? This is 30. Okay. Okay, thanks. So yeah, it is given it's 30. All right. So this is what this diagram which I'm showing you guys is the actual question, the one below in the black. Okay. All right. So you want to measure what? You want to measure EPD. This is E, and you have to measure this angle. Okay. All right. So let's mark this angle. This is the angle you have to measure. What is this angle? All right. So let's see. What do you know here? You want to measure EPD, which is essentially, well, this is the diameter. So this is 90 here. This is 90, we know. It's not a straight line. You should be careful with this picture. And this picture is better, I think. Slightly. This is 90. Um, how do you measure this particular angle? Let's see. So this is 90. That is 90. So this angle is same as this angle. And this is 90. So I think let's mark everything we know. So this is 90 here. Okay, because angle subtended by the diameter at a point is 90. We know that if I join this to this here, in principle it should be 90, because no, sorry, O if I join should be 90 because it's right angle, but I don't know that that's useful. We certainly know this is, we can calculate these two, but we want to calculate here. So how would we calculate this quantity? Um, you have to be careful. We have to again be careful. It looks 90, but it's not. This is not 90. There's no reason why ADP be 90. In fact, it cannot be because ODP is 90. Okay. Okay. So, hi everyone. So I can see the chat now, but let me just try to share my screen again. All right. So let's try to share my screen and let's see what happens. Now I can see YouTube. Okay. Is the screen visible now? Hmm. It's not yet visible. Okay, I'm sharing it. Sharing the screen. Not able to see. Now, okay, let's see it's sharing here. Okay. Still no. Oh, okay. All right. So you guys can see me now, right? So maybe just go to, let's try to scroll through screen time. Let's just okay. So how do I share my screen? I can do it on Teams directly. Screen share. Okay. Sorry. On Teams. Oh, I have never done it. So thanks, Naman, for telling me now. So yeah, I'm sorry. So let's see how to do this. Somehow, if ideally, it should be detecting my. I've done this before, where it detects my iPad for streaming, but it's somehow not working now. I'll give my input as whatever the issue is. Alright. Detect. Now it'll happen, I think. Okay. Let's hope. So let's screen recording. Send the text. Okay. Not detecting my art trust. Alright. I have no idea. So okay, so it does not let me edit. Alright, so how do I do this? So I can share, I think I can just go live on my iPad itself. It's much easier. Right? Then I can just share this screen. So let me just do that. I think we'll have to start another live streaming. Can I just join here? Let's see. So time to see problems on the spot. What's going on? Come on. We just I think I'll have to go live again. So that's nice. Oh, live. Cancel. Okay. Alright. I think there is no way to go live from, or maybe because it's happening. Stop stream recording. Right. So Okay, so let me try once more to go live. If not, I have to stop. Okay, so let me try once more. So it's mirroring now. Is it visible? Is it visible? Still not visible. Okay. Maybe stop sharing and reshare. That's the only last thing I can do. Okay. Cancel. Share screen. Share. Okay. I share. Try sharing again. Okay. I tried sharing again. So we can see. Okay. Fine. All right. So let's finish this problem then. Thank you. All right. Lots of technical issues. First time streaming. All right. So let's get to. All right. So let's. So how did you guys solve it? So in chat, let me know what you did to solve. So let me start thinking now on the question. Okay. Let's look at the question. Well, if you were allowed for a compass and a ruler, then you could have actually measured. Right. Okay. So this problem most people found hard. All right. So let's see. Okay. Let's see how to do this then. So you have a pair of tangents. Yeah. We have a pair of tangents. One thing to do is, we don't know whether this will help, is just joining these two, because you see, if you join that, then you know this is 90 and this is 90, and sometimes that helps, but actually this angle is what you want. So you start chasing. Will it help? So this and this is 90. That's same as this. No. So oops, problem of. Okay, so let me erase it. Okay, all right, let's let it be there. So I think I can erase it now. Okay. All right. So how do you do this problem? You want to label the angle x and try to chase angles. You want to find circles. Already there is a given circle in the problem, right? What is it trying to tell us? It's trying to tell us that what is really happening. There is a circle. There is a diameter. Okay. And the diameter subtends angle 90 degrees at some point B. Okay, that diameter subtends 90 degree at some point t. At that point somebody draws a tangent. Okay, and now that's a huge tangent. Wherever you want you can draw. I mean, wherever, I mean, that's a huge line. And now you choose a point p on it, such that when you join this and draw the other tangent, right, then the point of tangency and this line, when you join, this is 30 degrees. So how does one go about chasing here? uh, 90. uh, this picture is so misleading. I feel like I should draw a better one. but let's. This is always confused. I mean, this drawing is always confusing as if this is collinear. PDB are collinear. They are not collinear actually in the drawing. Should draw a better picture. I feel. Okay, or else let's just remember PDB are not collinear. How do I do this? This is 30. This, this is 90. That's for sure. What I've written 90 is for sure. Oh, so one of my student tells me that there are generally unsolvable questions in NMTC every year. But is this really unsolvable though? I mean, in the sense that we can chet test, right? In other words, yeah, it could be unsolvable in the sense that there may not be a unique X which will do the job. But if you could construct this, there will be an answer. You will not be able to find it, and it might be hard, but there must be a unique answer X, I think. So let's see. A, O. Can I construct this whole procedure? If I could construct it, it's not a problem. So you have B, then you have a movable point D. So you have a movable point D. Okay, D, B, A, and now at here you draw a tangent. Here you draw a tangent, and you find a point P, another point P. Now P is also another variable. So, and you draw, and then C will get fixed, and then you drop a perpendicular, and then you have no choice in the matter, and this will be 30. So now question is, this 30 degrees, can it always be fixed by moving P? I think by moving P you can fix it, but I have multiple solutions. Okay, so by moving P you can fix that 30 degrees, I think, unless for some reason it'll always be the same angle and it's some circle or something. And D also you could move. There were two variables. It's possible actually. It's possible in this case. It is possible unless some interesting thing happens. It is possible this has multiple solutions. But what could be the? This is 1990. This is a cyclic quadrilateral. Yeah, this is cyclic. This is 1990, and this angle. Yeah, it's possible actually. So we should draw it on GeoGebra and check actually whether there are multiple solutions. So let's actually check that. No, I think it's worth checking because sometimes maybe they are right and we are wrong, right? So where is GeoGebra? GeoGebra. Let's just see. Um, so you start with a circle. Okay. And you draw straight line. Then you intersect that with this. Then you intersect this with this here. And then we pick a point at moving point at random here. Okay. And we join this segment to this segment, and then we draw a tangent to this, and at this point then we take another movable point P. Maybe just this one I'll rename correctly to P. Okay. And now you will draw another tangent P. You would call it whatever E. And now we can drop a perpendicular to this line and join this segment to this segment. That is that should be 30 degrees. It's 37.5 now, and you keep moving it until it is 30. So maybe you can keep moving until it just becomes 30. But it doesn't matter, it need not be exact. Okay, whatever, 30.02, right? And you could measure, what was the question asked? You had to measure the angle DPE, right? I mean, whatever. So what was the question? You had to measure DPE, meaning the point of tangency P and the feet of the perpendicular. Point of tangency DP and the feet of the perpendicular. So wait, I did hopefully draw up a perpendicular correctly, right? Yeah, looks perpendicular at G. All right, whatever. So let's measure the angle. It's 37.72. There is no option called 37.72 here, I think. So it looks like a bonus to me, unless I made a mistake. I don't think so. We started with the diameter. We had a movable point. Nothing is close to 37, right? Is everybody convinced by the geometry, GeoGebra, everybody in chat? Is this fine? Yeah, it's a bonus, I think. Okay, wow. Dangerous. We don't know which question is bonus. So strategy in NMTC therefore must be like try for some time and it looks too complicated or it's not very clear, you move ahead. All right. Next question. The value of x such that 4 power x minus 3 power x minus half is 3 power x plus half minus 2 power 2x minus 1 is of the form a by b where GCD is ab. Then the value of a plus b by a minus b is equal to. So there is some x for which uh, you can find some fraction solution. Okay. Okay. Basically, some rational number is a solution to this equation, right? This is just straightforward. 4 power x and 2 power 2x minus 1 is also, you can write in terms of 4 power x by 2 minus 3 power x by root 3 is equal to 3 power x into root 3 minus. So you rearrange this to get 3 by 2 4 power x. This minus half of 4 power x and another 4 power x. This side there is 3 power x into 1 by root 3 plus root 3, which is 1 plus 3 by root 3. It's 4 by root 3, something like this. And then you, I guess, simplify everything. So you can 3 power x minus, if you divide by 3 root 3, it is 3 power 3 by 2. This equals 2 power 2x minus 1, 2 power 2x minus 3 or something like that. So I mean, just please check my calculation. So a power of 2 cannot equal a power of 3 if it was natural numbers, but I guess x is not natural. So now it can equal, right? But you just want one possible solution. Is that the thing? X is 3 by 2 works. So x equal to 3 by 2 works as their point. Actually, that's not the, yeah, maybe that's the only solution. Okay, anyway, at least x equal to 3 by 2 clearly works, right? 3 power 3 by 2 minus 3 by 2 is 0. So 3 power 0 is 1 and 2 power 0 is also 1. So therefore, a by b is 3 by 2. So a is 3, b is 2. So 5 by 3 minus 2 is 1. So 5. That's it. Okay. just a straightforward algebra. All right, next question. Okay, so this hopefully most people got. The number of polynomials x cube plus ax square plus bx plus c which are divisible by x square plus 1 is typical factor theorem question, right? If x square plus 1 is a solution, I mean x square plus 1 is a factor, then iota I square equal to minus 1, right? Iota, that is a root. So I cube plus ai square plus bi plus c is equal to 0 should happen, and that will instantly force minus I minus a plus bi plus c is equal to 0 by equating real and imaginary parts. We can always do that because a, b, c are integers, right? They're real numbers. So for real numbers, you can now equate a and b, a, b, c are real numbers. So for complex number becoming 0, you can equate real and imaginary parts. That's how you define equality of complex numbers. So b is equal to 1 and a is equal to c. Okay, so they wanted to know how many solutions are there for b is equal to 1 and a equal to c. Well, b is 1, no choice in the matter, and a and c can be equal. So pick any a you like, c will get fixed, right? So the answer is c, 12. Answer is 12 because any of the 1, 2, 3, 4, 12 you pick for a, automatically c will be fixed, and b is forced to be 1 anyway, no choice. So really the choice is here. Okay, so this is the usual factor theorem question. Okay, whenever you say divisibility, you know that this is a factor, then all the roots of the factors, all the roots of this must also be, all the roots of this quantity here must also be roots of x square. All the roots of x square plus 1 must be roots of x cube plus ax square plus bx plus. Okay. Right. Okay. So Pradyan notes that you could also do it by noting that a cubic into a linear is quadratic. So ax square plus 1 into px plus q must be, because x square, they've given a cubic, right? So essentially it should be x cube plus ax square plus bx plus c. Then he notes that because the is monic, meaning coefficient of x cube is 1, you're forced to have p equal to 1. That simplifies the problem quite a bit. So what remains is basically q, and then you just multiply out and check, right? So when you multiply it out, you will, I guess, get the expression x cube plus uh, q x square plus uh, x plus q or something like that you will get on the left hand side. So it will force b to be 1 when you compare, and again, just like we got a and c both to equal q, so q has 12 choices. I think that's the solution. Yeah, that's correct, Pradhan. That's also nice. Okay. All right. So problem number 6. Number of real solutions of the equation x plus 2 into x plus 3 into x plus 4 into x plus 5 divided by x minus 2 into x minus 3 blah, 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 is how many real solutions do you have here? Okay. So I mean, once x crosses a certain number, I think obviously if you keep adding and multiplying, it will only increase. So it will never be equal. It should be somewhere when it is small. Um, I mean, if you expand that equation clearly, degree 4, x power 4 will cancel and it will become a cubic polynomial. So even if it has, it can have at most 3 solutions, at most 3, but some of them could be complex. So we can try to see, guess by pattern. I think if you see x plus 2 into x plus 3 into x plus 4 into x plus 5 is equal to x minus 2 into x minus 3 into x minus 4 into x minus 5. So if clearly 0 is one solution, if you plug in 0, it's 2 into 3 into 4 into 5, 2 into 3 into 4 into 5. That's one solution. It can have at most 3 solutions because as a polynomial, as I said, x power 4 will cancel, it will be at most be cubic, right? So in fact, it will be a cubic. So it can have at most 3. 0 is one of the real roots. Even if it gets one more real root, since complex roots come in pair, the answer is 1 or 3, first of all. If you had no time and you had to guess, it's either 1 or 3. That's for clear. That's clear. You just have to figure out between 1 and 3 what it is. Okay. So all right. So let's see what. So I think you can, if yeah, you can expand this and multiply. X power 4 will get cancelled, and x square coefficient also will get cancelled by symmetry, because minus 2 into minus 3 and 2 into 3, minus minus is plus, right? Because of that. So one thing is, now you can expand just the cubic term. The cubic term is 2 plus 3 plus 4 plus 5. So that is 5 plus 4, 9, 3, 12 plus 2, 14. 14x cube here. On the other side, you'll have negative of 14x cube. So 2 times 14x cube plus this pairwise product term, x square terms will get cancelled, because x square is 2 into 3 here, and x square into minus 2 into minus 3. Basically, essentially, you'll get the same terms on both sides. Okay. So the only last remaining term is the constant term. So the constant term would be 3 to is 120, I think, right? Is equal to 0. So that's what you will essentially get. This is the x term. Sorry, the x term. No, for 120 will also get cancelled. What you get is the x term. I'm sorry. For x term, you will get 2 into 3 into 4 plus 3 into 4 into 5, whatever. So you'll get 120 by 2 plus 120 by 3. That's the term that will remain. 120 by 4 plus 120 by 5. Okay, this term will remain, is equal to 0 into x. So if you take that x out common, that x equal to 0 is that root, and the other root is 14x square plus some positive quantity is equal to 0, and that will give you complex roots. I think the answer is 1. Let's see how they solved it. Let's see if some students solved it. Yes. Yeah. Okay. All right. So you don't even have to solve the full thing. I mean, like, you can just quickly note that without solving the full thing, you can note that will be of the form some x square plus some. Yeah, answer is 1. If a is root 23a plus b, b is root 23b plus a is not b, then what is the value of a square plus b square plus 48 whole square root? So a square is 23a plus b, and b square is 23b plus a. I guess you can add the two equations or something and complete the square. This is the kind of thing we do, right? 23a plus b plus a plus b. Also, it's a square, sorry. It's just 24a plus 24b. And this is the usual completing the square thing. I'll try first. If it works, it works. A minus 12 square plus b minus 12 square is 288, I guess. That's one thing to try. It's basically intersection of like two parabolas. It's funny that they give a is not equal to b, just to make sure you don't solve it easily. Why not? I mean, if it works, why will it stop working at a equal to b? There's no divide by a minus b or anything here. Maybe, is it because you plug in and make sure a equal to b equal to what? 24 should work, right? We'll just ignore them. Ignore them and put a equal to b equal to 24. Will it, what is the problem? Will it go wrong? 24 square plus 24 square plus 48 square root. What is that? So a is 24 works, right? If a equal to b equal to 24, yeah, it works. So 24 square plus 20 square 4 square plus 48, what is it? It is 4. Okay, 24 you can at least take common out. 24 twos are 24 square. If you take 24 common out, it will be 24 plus 24 plus 2, and this is 48, 50. So this is 24 into 50, its square root, which is essentially, it's not nice number. Did anyone get? But they didn't say a is natural. Yeah. So okay, so maybe there are two roots. One is a equal to b, and the other one is not a equal to b, and that is why that's why we are not able to get. I'm wondering why like a equal to. I mean, I'm ignoring the condition. 2 into 24, 48, 50. It's not working, right? It's definitely not working. 25 into 48. It's 5 into something. So that's certainly not one of the options. Okay, so maybe the point is that there are two solutions, one of them where A equal to B and the other where A is not B. Okay. All right. I guess the point is that if you do 12 square 144, 12 root 2 is this is 12 root 2 square. So if you want, you can just do it via parameterization of a circle. A plus 12 root 2 cos theta, B 12 root 2, 12 root 2 sine theta, and just plug in here, right? Uh, Actually, I'm solving this addition, but really this B here is 23 square minus A. If I plug in here, in principle, it can get complicated. 12 root 2 cos theta and sin theta will make it complicated here. The thing is that when you go from here to here, you lose information, right? From here to here, you're losing information. So we are adding, right? Because when we add, we lose information. We can subtract, I think. Why only add? A square minus B square is 23A minus A is 22A minus B, correct? And adding is 22, right? If A is not equal, this is where A is not equal to B is used. See, A not equal to B, A minus B I can cancel. Will force A plus B to be 22. Okay, that is the main point. Okay, so you don't need this. So just take A plus B is 22, subtract. Okay, so now we have A plus B is 22. We can write one in terms of the other, and we are done. We get a quadratic. A square is 23A. Now the problem is over. 22 minus A. B is 22 minus A. We get a quadratic. So A square is 22A plus 22. Okay, and B square is also similar. B square also is same logic, symmetric, 22B plus 22. And so if you add A square plus B square plus 48, like they asked in the question, it will become, if you add the two, 22 square plus 22 plus 48, which is 22 square plus 70. What is 22 square plus 70 square root? Bigger than 22. And ending with 4. Isn't it? Ending with, sorry, this ends with 4. So the square root of it will end with, which are the squares here? That could work. Okay. A plus B is 22, that's correct. So B is 22 minus A, so 22A plus 22. B square is 22B plus 22, up to there it's correct. And A square plus B square plus 48 is, hopefully I've done all the arithmetic correctly. 22A plus 22B is 22 times A plus B. When you add these two, you'll get 22 times A plus B, but A plus B is already 22. So you'll get 22 square. And then, but you'll add 222, so you'll get 44. 44. And this is 92. 92. So basically 2 square is 4, 4 plus 2 is 6. Something that squares to 6. Among the three options is only 24. Because I think answer is 24. Can anyone check whether what is 22 square plus 92? I think we should be able to get 92 is 46 into 2. Yes, it's 24. Okay, awesome. Oh god. Okay, so I think we know what to do now. Switch off. Stop sharing. Share task. Okay. Now is it visible? Yeah. Okay. Problem number 8, in the adjoining figure, PA, PB are tangents to the circle. AC is parallel to PB, measure of CDE. Measure of CDE. PA, PB are tangents. Okay. AC is parallel to PB. I mean, what? What is this question? Okay. 180 minus 108. This is 54. 54. Right. And parallel also. So this is also 54. Correct. What is the measure of angle CDA? What is the measure? You can join this and this angle are supplementary to each other, and you can calculate what this angle is. Right? You just calculate that angle. 72. Wait. AC is parallel to PB, and just a minute, just a minute. So, oh, but AP is parallel to CB. I don't know, so I can't say this is 54. Okay. So what do we know? Uh, what is this angle anywhere on D is the same. So where is the tangent though? Ah, by alternate segment theorem. That's correct. Alternate segment theorem. Correct, correct. Nice. So 54. So the alternate segment theorem, the angle subtended here is 54. Right? This also is 54 by alternate segment theorem. So this angle is also 54. So angle subtended here is 54. From that, can we say what this angle is? And we are done, I think, right? So basically, whatever is this angle plus this angle is 180. But if this is x, this is 180 minus x. But then they add up to 180. So move 108. Right? Yeah, I think the key point was alternate segment theory. This is 54. So this angle is 54. So I think, okay, all of you did alternate segment theory. All right. Very good. Okay, either way, I think you can do this in multiple ways, but the main thing is alternate segment theory. Let's move on. Let's do it quickly. Next question, some arithmetic looking question. 19 power 8 plus 19 power x is 19 power x plus 1 is 361. So subtract or something. 360. Done, right? 19 power x plus 1. So what is, oh, sorry, 361 square, is it? 361 square minus 1. 361 is what? 19 square. So it's 19 power 4 minus 1 is equal to that. 19 power 4 minus 1 cuts 19 power 8 minus 1 as 19 power 4 plus 1. So 19 power x plus 1 equal to 19 power 4 plus 1. So x can equal 4, for instance. If x is 4, you check which one of these equations satisfies x is equal to 4. Right? So that's it. So we have to check which one equals 4 over what. A little painful. So 12, 3, option D apparently. Okay. So I'll believe you. Let's just check that directly. 3 into 4, 4 square, 12, 3 is 36. Minus 44. 4 square, 16, sorry. Since it's a 48. Minus 44 minus 4, yeah. Is equal to 0. 16, 3 is 48. Correct. D satisfies. Okay. Direct question. Basically, you just had to note that 361 is 19 square. And then just direct. Okay. All right. So some questions are just a little too easy, actually. All right. Next is S is 4 plus square plus 2 5 square plus 3 6 square dot dot 25 28 square. What is S by 325? What is the formula here? N plus 4 the whole square into, or maybe we should say n plus 3 the whole square into n, is it? N is 2, 2 plus 3 is 5. N is 1, 1 into 1 plus 3 the whole square. Okay. So this summation n equal to 1 to 25. So you have to sum this, and this is the usual, I guess. Everything is up to cubes, no? 9n square, if you like. I don't know whether which is a better method. You can, anyway, it doesn't matter. 9, sorry, 6n plus 9. I mean, the blind way to do this is the blind way to do it. Maybe there's some smarter technique. 6n squared, 9n, and waiting from 1 to 25. Now we apply all formulas. I mean, n cube summation we know is 25 into 25 plus 1, 25 into 25 plus 1, 26 by 2 whole square, summation of n cube, basically. Summation of cubes is this formula. 6 into summation of squares is n into n plus 1 into 2n plus 1 by 6. Okay. Plus 9 into summation n is 25 into 26 by 2. So that's what the summation is. This is the summation. And once you get the summation, you can simply divide by 325. Now 325 is what? I mean, 5, 6 are 30. 6 are 30, 565, 65. So it's 25 into 13. 25 into 13, I think. Okay. So to divide this S by this entire thing by 25 into 13. That's the answer. So one thing is, I guess you can cut off 25 in many places like this. And here another 25 into 26 we'll write by 2, and we'll cut off 125. And I'm surprised actually that the answer is some small number. Okay, so 113 you can cut off with 1 2, and you can cut off with the 2, you can cut off with the 2. So what remains is here is this 2 cuts with this 2. I mean, I make so many, it's highly possible I'll make mistakes. So 25 into 13, first term is 25 into 13. The second term is 2 into 51, 102. Last term is 9. So how much is 13 into 25? Well, that was, we know, 325 plus 102 plus 9. I hope that answer is there. 427 plus 9, 436. Is it there? It's there. Okay. So I think it's mostly correct. All right. So all right. So the main idea is you just had to, as usual, write this expression in general n form, a summation from n equal to 1 to something. In the general form you write down, guess the general formula, then expand it and write it as sum of cubes, squares, and stuff. And then you can always use standard formulas. It's very scoreable. Okay, these things you should not miss in an exam. Okay, 11th one. The sequence an is that a1 is half and an is blah blah. Then what is the sum of values? So a1 is half, and did anyone get this? An is an minus 1 to an minus 1 plus 1. Looks like it's some an minus 1. If you write down, you see pattern, is it? So all of you got it. Okay. An, okay, let's see for a minute then. So you guys notice the pattern by plugging in values. Like if you put a1, a2, a3. So if you put a2, you will see it's a1, 2 2s are 4a1 plus 1. That is half by 3. Is it half by 3? Half. 4a1 is what? 2 plus 1, 3. So it's 1 by 6. Was it 1 by 6? Sorry. So 1 by 2 plus 1 by 6 was, I mean, a1 plus a2 is 1 by 2 plus 1 by 6, which is 3 by 6 plus 1 by 6, 4 by 6, 2 by 3. So a1 half, next is 2 by 3. And if you see once more, a3, when you add up, finally it becomes, you can actually immediately, you sort of guess that the answer must be an is n by n plus 1. Okay, so the guess is an is n by n plus 1. Actually, one of the easiest ways to prove it, really, to convince yourself, is to plug in the formula. That is, you can just plug in an is n by n plus 1 into this and check. It's like induction proof. You can assume up to n minus 1, and then you can just plug in n minus 1 by n. I mean, if, oh, we are checking for the full sum, right? So yeah, you can check up to an minus 1, the answer is um, n minus 1 by n. Then plug in and check what do you get. So, I mean, you can do it by telescoping. Right. So I guess if we observe that, we saw that a1 plus a2 is 2 by 3. How do you really solve it though? I mean, is there some nice telescope? Yeah, apparently telescoping will work, is what one of the students is saying. So let's just see whether it is true. How do you do it? So a n plus a n minus 1. What makes telescoping work actually? I mean, what you can write a n as a difference of two terms. 1 by 2n plus 1 by n minus 1. Is this helpful? So 2n a n plus 2an by an minus 1 is 1. So, oh, I see. 1 by n, if you divide by n, is 1 by n minus 1 plus 2n. So, at least there seems to be telescoping for 1 by n, at least. Right? So, if you do, but if you want to write a1 minus an, then what will happen? So, a, I don't know how you'll telescope actually. So you can basically find out all the terms of the sequence using this recursion and then finally calculate, I think. So the correct way to do this could be, oh, but then you have to find out a1 plus a2 plus a3. So essentially, this is, you can telescope this now. You can telescope 1 by a1 is equal to 1 by a2 is equal to 1 by a1 plus n is equal to 2, right? 4. And you can keep writing this 1 by a3 is equal to 1 by a2 plus n equal to 3, 6, and so on. And then you can essentially, when you add it up, you can cancel, you can telescope all the 1 by a2, 1 by a3, and everything. And you can reach up to whatever 1 by an is equal to 1 by n minus 1 plus 2n. And you'll get, everything will cancel, and you'll essentially get, by telescoping, 1 by an is equal to 1 by a1 plus 4 plus 6 plus dot 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 up to 2n. So it's 1 plus 2 plus 3 up to n. So n into n plus 1 by 2, something like that you'll get. So therefore, you'll get a general formula for an. And then you can plug in an here and sum it up if you wanted to do a proper proof. Anyway, I'll skip that, but this is the idea. You could telescope this. The main idea is you could rearrange this expression by dividing by n minus 1 below. And when you rearrange the expression, you get a thing that gives you the difference between 1 by n and 1 by n minus 1. That's the main point. Okay, so let me just full. I mean, if it was a RMO question, you have to really, RMO won't be this easy, but if you get an RMO question and you have to write out the full proof, how would you do it without trial and error? Okay. All right. So basically, the answer is 2024 by 2025 is the guess. Okay. If alpha and beta, uh, alpha greater than beta satisfies some equation with the log, then what is alpha plus 1 by beta? Okay, let's quickly solve this. So x power 1 plus log is x power 1 into x power log x base 10, okay, is 10x. So I don't know why they are saying this. So one of the roots definitely can be x equal to 0 if you want. Okay, I don't know whether they want a non-zero solution. Clearly, you can cancel x on both sides here. So, but x equal to 0 means log 0 is not defined. So x0 is not allowed, I think. So uh, now how do you deal with x log x base 10 is equal to 10? Okay, so yeah, 0 is not allowed because log 0 is not defined. So okay, now you have to solve this. What do? You take log again. Log x base 10 into log x base 10 is equal to log x base 10. Okay, so take log on both sides, base 10, log 10 base x. Log 10 base 10, whatever, is 1. So you basically get log x base 10 is plus or minus 1. So x is equal to 10 power 1 or 10 power minus 1. So x is 10 or 1 by 10. So if alpha is bigger than beta and alpha is 10, 1 by 1 by beta is 10, so answer is 20. It's a very easy question. Okay. Just knowing the definition of log. Lots of these log questions are so easy. It's like just knowing the definition else allows you to solve the problem. Okay, great. I think hopefully most of you got it. In the adjoining figure, 4 successively touching circles are placed in the interior of angle AOB. The first has a radius of 7. The third has a radius of 28. What is the radius of the largest circle? Okay. So I guess the key point here is if you knew, I guess for one, all these are on a straight line. Right? Did anyone solve this question? So actually the smallest one has a radius of 7, but we are going to draw it here anyway, regardless. This one has 7 actually. This one apparently is 28. And one thing is that you could notice that these are similar, but the point is by what is the ratio? So successive difference. You can solve this by noting here what is the difference. Essentially, what is the radius? Does it maybe matter on the radius actually? How much does the radius change by? Like if you go from here to here, how much is the radius changing by every time? You should be able to tell, right? So given this is 7 by 28, you can maybe say what happens to the radius. So, I mean, this is radius 7, this is radius 28. What is the in-between radius? I think we've done this question before, no? This kind of a question we've done before. You have something like this, and you have done something like this, no? What is the relation between the radii? The distance between them should drop a perpendicular here, 90 degrees. Then if this is R1, this is R2. And if this distance and the length of the tangent we don't know, and this is R1 plus R2. So from Pythagoras theorem, we can tell this is R1 plus R2 is R1 minus R2. So therefore, the Pythagoras theorem, we can say this is 4R1 R2, square root of 4R1 R2. This is 2R1 R2. That much we can tell. So we can tell the distance between, I mean, the length of this tangent we can tell one thing. One thing is for sure. But would you be able to tell, given this radii, will you be able to tell this radii actually? Can we predict? If you could predict the radii, we are done, right? That's what we want to do. Main question is, if I tell you this radii, what other things can you tell? So, did anyone solve this question? How do you solve this though? Wait. We solve this. Sorry, not able to see. Not able to see comments. Okay. So what is start with 7 here? I think the main point is you can draw given, I mean, it depends on the angle, right? I mean, it depends on the angle, obviously. So maybe from the 7 and 28, you can tell the angle. And once you get the angle from there, you can predict all the radii. That's the point, right? Oh God, of course. All right. Got it. Okay. I think the plan is clear, right? Plan is clear. So let's do this. Let's try. So, I mean, it's done for 3. It's too small here to actually. Okay, maybe I can zoom in. Okay, the plan hopefully is clear to everyone. So you just take this length and you drop this. Okay. So they've told you this is 28, and they've told you this length is 7. So you can drop basically a perpendicular. Okay, I mean, it doesn't look perpendicular because I have not drawn this exactly perpendicular. So let's draw this as perpendicular as we want, like this. Then you drop here, and you know that these are collinear. All the centers are collinear with the. All the centers are collinear essentially. Okay, like this. And now this entire length is 28, and this length is 7 here. This length is 7 radius. So now that means this is 21. This is 21. And oh, again, we cannot tell, right? So this is, we can't tell, you're right. So this is 21, 28. This distance is 28, but then we don't know this 2 times the radius in between, we don't know. So we cannot tell. That's partly the problem. So 2r here, the diameter, plus extra radius 7. So we can't tell the angle because of r again, but then it relates to r. So we can again try to calculate from there. So double will get something. Okay, yeah. So this angle, okay, all right. So the plan is this and this line are parallel to each other. So this angle is the same as this angle here. So whatever is the angle made here, alpha, okay, this is alpha. This also is alpha. So therefore we know, for instance, sine alpha is 21 by 35 plus 2r. 35 plus 2r. Maybe we should have done it directly on the larger radius instead of the smaller one. But anyway, 35 plus 2r. And now again, we can try to calculate sine alpha in a different way, hopefully. Okay, so this is one sine alpha. Another we'll try to calculate, somehow including this radius. So if you try to calculate, this angle is alpha again. And maybe we should be able to calculate from this small piece here. Again, this alpha. This entire radius is r. So we do, this is r minus 7, this piece here. And this sum is r plus 7. So sine alpha is also r minus 7 by r plus 7. So we can rearrange and get r, is my plan. I don't know how good that plan is. 35 plus 2r into r plus 7. I think we should be able to get it. 21 into r minus 7. Sorry, r minus 7. Okay, is this fine? I hope it's clear to everyone. R plus 7. So 2r square minus 14r plus 35r minus 7 into 35 is 21r plus 7 into 21. So you get some quadratic for r. I'm hoping only one root for this. Okay, so is this fine? I mean, hopefully this is clear. Oh, most people guess the answer by. Oh, I think in chat people are saying they guess the answer. How? Plus 21r. Oh, 21r cancels. So sweet. Okay. Okay. 2r square is 7 into 56. 7 to 28. So this is 7 square into 4 square. Wow. Nice. It's a unique answer actually. 28. R is 28. So what? Uh, Something's wrong, no? R is 28 is certainly wrong because it's already 28, no? I think there should be another answer actually. What this is doing is, I made a mistake. So I think, sorry. 7 into not 4 square, 7 into 2 square, right? 7 into 28 is 7 into 7 into 4, 7 into 2 square. Yeah, thank God. It's 14. Okay. It's like what? It has to be less than 28. 14. Okay, fine. All right, awesome. Now we are in business. So basically, we are done, right? I mean, this essentially is 7. This is 14. This is 28. And I guess, as you guys say, maybe this will be 56. I don't know. But we can calculate that now. So you basically calculate this and you take, we don't know whether it will be 56, but you take the entire to be R. Then you keep this to be 28. So this is R minus 28 and this will be R plus 28. So R minus 28 by R plus 28 is again sine alpha. And sine alpha, we already know if you put R is equal to 35, as R is equal to 14, it is half. No, not half. What is it? If R is equal to 14, 14 minus 7 by 14 plus 7 is 1/3. So basically sine alpha is 1/3. So if you rearrange, you'll get the answer, which you guys think 56 maybe is correct. Who knows? 28. So 56. Again, we might be making so 3 into 28. So that's if you rearrange, just a minute, you get 4R. Oops. You get 4R. No, not 4R. You get 2R. 3R minus 3 into 28 is R plus 28. So 3R minus R is 2R, is 4 into 28. So R is 2 into 28. I think it is doubling. It's 56. So if you guessed it is just doubling, most likely you got it right without doing the full problem. I think essentially because R minus 7 is basically sine alpha being 1 by 3 is basically doing it. I think it's doubling the answer throughout. R minus A by R plus A is equal to 1/3, means 3R minus 3A. I think just generally checking whether it's always doubling. It's 2R is 4A. Yeah. See, R is 2A. Started with the radius A, it doubled next. Yeah, so it is doubling. Awesome. So if you guys guessed it, great. Okay. Answer is 56. Awesome. You saved some time. Okay. All right. So all of you guessed answer 56. Many of you guessed 56 in chat. Okay. And some of them said. Oh, okay. All right. There's negative markings, right? So that discourages guessing. The coefficient of x in the equation x squared plus q is equal to 0 was taken as 17 in place of 13, and its root were found to be minus 2. The coefficient of x was taken as 17 in place of 13. Okay, it's actually originally 13, but somebody wrote 17 and found minus 2 minus 15. If alpha and beta were the roots of the original equation, then the equation whose roots are alpha by beta and beta by alpha is. Should be straightforward, right? It seems somebody put 17 here and got the roots to be minus 2 minus 15, which means the product of roots is 30. So this was the equation they mistakenly wrote. But original equation should have had 13. So it should be x squared plus 13x plus 30. Its roots were alpha and beta. So I guess you can try to see 30 is 15 into 2 or something like that. 15 minus 2. Or you don't even have to do all that, right? I mean, you can, if you want, directly work with alpha by beta and beta by alpha roots also. Sum of root, product of root, you can do product of root. Then the equation whose root is alpha by beta and beta by alpha is obviously the product of the roots is 1. So all the options have that. So that's not very useful. So the real thing is the sum of roots. Sum of root is alpha by beta plus beta by alpha. And Vieta's formulas, right? So alpha square plus beta square by alpha beta. And alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta by alpha beta. And now alpha beta the whole square, alpha plus beta the whole square is 13 square minus 60 by whatever 30. So this is the sum of roots. So you will get 169 minus 109 by 30 or something. So it should be a 109 somewhere, and there should be a 30. It's this. So sum of roots is 109 by 30. So minus sum of roots should appear. So there should be a negative sign. So I think the answer is C. Okay, direct questions. Very surprising sometimes. Extremely direct questions. All right, this one. 1 plus xy plus x plus y the whole square minus 1 minus xy plus x minus y the whole square is ky into 1 plus x square. What is k? Okay, how do you solve this? Well, one thing to note is 1 x plus xy plus x plus y is x plus 1 into y plus 1. I think the pen, I don't know this is visible to all. X plus 1 into y plus 1 the whole square minus x plus 1 minus y x plus 1 into 1 minus y the whole square. So you take x plus 1 the whole square out. 1 plus y the whole square minus 1 minus y the whole square is 4y. So k is 4. What? This is just too easy, right? If you expand, it will take a long time though. If you expand really a plus b plus c plus d formula. If you noted that this is very easy, right? There's a square here by the way. So this is 1 plus x the whole square into y plus 1 plus y the whole square. Yeah, if you expand, okay, some students are saying they expanded. If you expand, you'll get it, but it'll take time. This is very fast, right? Like 2 lines. It's so fast. Okay, section B. Hopefully, I'll finish it in half an hour. You might go up to, okay, you guys have to leave by 9. Some people in the chat have to leave by 9:40, so try to finish by 9:30. Whatever we can. So x power 10 plus 1 divided by x square plus 1. Again, okay, we get something, all right, as quotient. Then the value of blah 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 per everything raised to the power 2024 is.